Good morning, everyone. I'm going to introduce you the second generation beacons. Cospas until now had only one generation of beacons, the first generation beacons. Every beacon that you have had in your hands or you assisted in your RCC or Spock, it has been a message from a first generation beacon. A new generation of beacons that is called the second generation beacon has been created using a new modulation technique and a new bit structure. This gives us some advantages. One of them is that, in principle, we will have more location accuracy on the DOA locations, and the signal itself will be more robust against the interferences. Also, there is a new bit structure which is longer than the one used for the first generation beacon. This longer bit structure will allow us to have a better encoded position resolution and will port to the Spock and RCC auxiliary information that cannot be accommodated within the first generation beacon. And we have things like remaining battery capacity, beacon altitude, or even providing alert cancellation, among other things. The bits in the information world is to the Cospas at 406 MHz message what the letters are to form a sentence in your language. We use the bits to form words. So we group in any number of bits, starting from 1 to whatever longitude we want. And with these words, we create a sentence. And the sentence we are talking about here is the 406 MHz message. In the comparison between the first generation and second generation beacon messages, the second generation beacon message is longer, and this will allow more information in that message. We can see how the long format message for the first generation beacon has only 87 bits protected. In the second generation beacon, we have 202 bits. This is in principle also because the first generation beacon needs some synchronization for the signal to be recovered in the LATs. The new spread spectrum modulation technique that I commented before, that is a new one, has like a password that make us demodulate the signal without using the synchronization. So with the second generation beacon, we have more bits, a longer word, and more bits protected. We have also the identification the RCC and Spock is going to use to identify the beacon. Is the 15 Hex ID for the first generation and the 23 Hex ID for the second generation beacons. So with a quick look, we'll have a second generation beacon message that consists of 250 bits and with 48 bits with a new kind of field. We are going to call it the rotating data field. These 252 bits that are at 2 bits by the LAT comprise a 63 hexadecimal character message, but this is too long to work with it. So for that reason, we are going to use the Hex ID, which is only 23x long. So as indicated, we are going to use a new kind of field that is a rotating data field. It is a portion of the message that not always means the same. There is a header that will indicate that we are talking with a special rotating data field, and there we are 15 possible combinations, so the information in those bits can change sometimes from one burst to the other. So the same beacon is able to expand the information it provides to the RCC and the Spocks because this rotating field is changing, and as we will see later. This is the basic structure of the new second generation beacon message. So we have a Cospas type approval certificate and serial number fields, the country code, homing signal. This is only 1 bit for RLS, 1 bit for test, the position, the vehicle ID, the beacon type, and the rotating fields. In essence, this is the usable information that we are going to have in our hands. The type approval certificate has a number given by Cospas for every beacon model that passed the exams to be a formal approved Cospas beacon. And for that model, the manufacturer can code inside the beacon up to 16,384 different unique identifications for that model. So imagine we have a lot of possible beacons. This data cannot be changed. So the beacon is manufactured given this pair of numbers, and when the beacon dies, this number cannot be reproduced again. But we have plenty of numbers for that. the type approval certificate allocation table. This is a very interesting table because the type approval certificates are going to be given in ranges. And some ranges have been allocated for several beacon types. We have a range to ensure that we are not going to collide with the first generation beacons. There is a range for type approval testing. There are 4 ranges for operational beacons, PLBs, EPIRBs, ELTs, and ELTDTs. And then for research future use, we have plenty of type approval certificate yet. The 23X. As you can see here, the 23X does not have the beacon type. It was presented before in the complete second generation beacon message there is a beacon type, but here no. So if we look at the type approval certificate together with the previous table, we will know that the beacon should be a maritime beacon because it is in the range. Normally, the RCC or Spock should not be concerned about that because the MCC is going to send a narrative message special C985 that will provide the beacon type with the information stored for that type approval certificate, as you will see later. So this 23X ID will be our reference in the MCC and in the Spock RCC to know what beacon we have in our hands. With this kind of decodification, if you can go into the page of COSPAR-SATSAT in the beacon decode tool and put in the 23X ID, although the MCC can provide some information on the beacon, you always have the possibility to decode it. The vehicle ID. The vehicle ID is the ID of the vessel or the aircraft that is carrying the beacon. Sometimes this field is set to nothing, maybe zeros, maybe ones, or whatever a national authority has defined for it. So for that reason, the vehicle ID, although one at first could see that if it is an aircraft or a vessel, this is not always possible 100% of the time. For this reason, the type approval certificate ranges give us the type of beacon we are talking about in every moment. This is when I talk about bits and words. This is a word. We have a word of 3 bits. And with this word, we can say many things, at least 8 different things. We can say, for example, we are dealing with a maritime MSI or radio call sign or aircraft registration marking. And depending on the information we have here, the 44 bits will codify the aircraft vessel ID, will have this kind of information. Maybe we have an MSI, an AIS, or we have a radio call sign or an aircraft registration marking, etc., etc. This is the way that we use the bits within the message. We group it in words and get meaning from these bits. In the 23X message, we have also the country code. The country code that is 3 numbers that is given for every country. There is 3 numbers, and one you get the numbers and you can know what country the beacon is registered in. We also have the test flag that this is 1 bit. This flag will indicate if the beacon is in test mode or normal operational mode. But 99% of the time, you will not receive a test protocol beacon in that way. The position information. In the complete message of the second generation beacon, we also have the position information. Usually position information is an optional capability, but an ELTDT has to provide the position information. In flight, it is mandatory to use it. The position information is coded in this part of the message. So from the bit 44 to the bit 90 of the complete 252 bits that I already mentioned, you have 23 bits for the latitude and 24 bits for the longitude. And this provides us with a resolution of 3.4 meters. So the capacity of the beacon to store a location is in a grid of 3.4 meters. When we send the messages to the RCC and Spocks, we will make a note about the position accuracy provided is approximately 10 meters. One thing you can write in the beacon message, which is very, very, very short, but you have to take into account that the position provided by the GNSS is not always precise as one wants. So at the moment, if you receive a C185 message for a second generation beacon, you will have the sentence of the 10 meters, not 3.4 meters. This is more or less what we have increased in the resolution. In the black dots are the position that could be provided by user location protocol beacons. This is 4 minutes, about 7.4 kilometers. It depends. Say 7.4 meters at the equator. In the north, it depends. For the meridian, it is 7.4, but it's always latitude dependent, so it always refers to in the equator longitude. First generation beacon is the blue grid, so we have about 100 meters between the blue dots, and this is the resolution that we can reach with the second generation beacon. We have very, very fine resolution possible in the beacon message. The beacon type. Again, we can have a word here of 3 bits, and with this word, we can indicate what type of beacon we are talking about in every moment. This is the information that is in the 63X, but it's not in the 23X. And for this reason, we have to use the tag table that I told you before. If you only have the 23X to know the beacon type we are talking about. So there are 4 defined types, one for system beacons, ELT, EPs, PLBs, and ELTDTs. The rest are spare at the moment. And we have the rotating fields, very interesting addition in this second generation beacon. So we have some fields that with these 4 bits, we are going to identify what rotating field we are talking about in every moment. The normal beacons have to transmit at least once the sequence per subset documents G008 objective requirements. So the rotating field for complying with the objective requirements, that is the first rotating field, we have the elapsed times in activation, given in hours, the time from the last encoded location, given in minutes. So we know how old the encoded location is that is being provided from one position to another one, because if the encoded location for some reason is very delayed, we want to know that the position is 20 minutes old, for example, because the vessel could be drifting and it is not anymore at this point. It's in another place. The altitude of the encoded location. We also have the dilution of precision, so we know if the GNSS is fixing the good position or is dispersed, it's not very good. We have the mode of activation, if it's automatic or manual, the remaining battery capacity, and the GNSS status that give us information if it has a 2-dimensional fix or a 3-dimensional fix, or there is no fix at all. With the rotating field for ELTDT, in flight emergency, we have also the time of the last encoded position, and this is the time in UTC. So we know in seconds the time when the burst is produced. This is the first time we have this in a normal beacon. We also have the altitude, the triggering event, so we will know if the beacon has been activated by external means or by a manual activation, or if it is a post-crash activation by a G-switch. The GNSS status, again, will give us the 2-dimensional fix or 3-dimensional fix. We have also the remaining battery capacity and some bits that still spare. For return link service, we have the beacon RLS capacity, the RLS provider, like Galileo, GLONASS, Beidou, and the beacon feedback. And we have one for national use, that of course it is all blank because it's the national authority who define what is in there. And we have the cancellation message. The rest of them at the moment are spare. This is the rotating field table. So all beacons except ELTDTs, beacon with RLS functionality and national beacons will send this rotating field only. ELTDTs will send only rotating field number 1, but the RLS, for example, send the rotating field number 0 and the rotating field number 2 alternatively. They begin to sending rotating field number 2 and then switch to rotating field number 0, then rotating field number 2 and number 0, expanding the amount of information that the same beacon is giving at the time. Here is a comparison between the 185 for first generation beacon and for second generation beacon. The first thing that you will note is that in the 4th line you see the SGB letters, so you know that we are talking about the second generation beacon in this message. Another clue is the Hex ID, which is much longer than the one for the first generation beacon. As you can see, in the detection and location part, the red one, we have, for example, the time since the GNSS location was provided or the altitude of the beacon, which is information that we cannot provide for regular beacons here in the first generation beacon. And what I mentioned before about the 10 meters, this is how we are going to set it. Although the resolution is 3.4 meters, we are going to set this information here at 10 meters. There is no contradiction. It is what we have now in the procedures. the remaining battery capacity, elapsed time since the activation, as I told you before, much information we have. This is the new narrative the MCC is going to send to the RCCs and SPOC, indicating some information extracted from the tag number. Based on the tag number, the tag table that I told you before, there is different ranges for different type of beacons. We will recover this information from the beacon and we provide you in a message like this. So you have the 23X and the type approval certificate and some information that informs that it's flood free. There is a navigational device, the brightness of the flashing light and whatever. This information is auxiliary information that will be sent, I guess, because we don't have this operational running at this time. Now we are going to see a simulated scenario. The scenario, of course, this is created for this presentation. Sometimes in the real world, things happen very differently. I have introduced a beacon that first is sending a message and is located, and it's an RLS type of beacon. The beacon will send information on the RLS capability, then will send information about remaining battery capacity and so on, and we will see. Alternating from fields number 2, number 0, and then we are going to force a cancellation. You'll see the use of the reference 15. We have a timeline, so the beacon transmits the first burst, and the first burst transmits the field number 2, indicating the beacon RLS capacity and the RLS provider. In principle, the beacon feedback should not be anything because the beacon has already activated and has not received anything from the satellites. On the second burst, the beacon takes opportunity to send the message feed number 0 and indicates the elapsed time since activation, time from the last encoded position, the altitude of the beacon, and remaining battery capacity, and so on. On the third burst, the beacon has already been located and confirmed, so the beacon has received, in the beacon feedback, the information, it is not here, but we will see later, information that the beacon has been heard. The user know about it, it realized that the beacon has been activated and pushed the button to cancel the alert. At that time, there is a consecutive series of transmissions, all of them with a cancellation message. And on the third one received and validated at the MCC, the alert is considered cancelled. So the MCC will cross out the alert, will keep it in standby, and if the alert is reactivated, the MCC will close the one that was in standby, open a new one, and send you a new alert. So this is more or less what you will receive in one of the bursts. In burst number 2, you will receive the information from the tag, so all the information related with the device itself, and the only thing that inform is that the beacon has return link capability. As you see in the first line, it's an initial alert, it's unlocated, and there is no more information. It's a second generation beacon, of course, and it's a PLB. So now we have an initial located alert with the second burst, which is the reference field number 0. And here the beacon informs about all the fields that I have already mentioned. They are described in this part of the seed message. The activation type is manual. It is indicated in the third section. In the fourth section, it indicates the time. It's the information related with the position. Of course, because for that reason is in the section 4 that is marked in red here. And in the brown area, the section 5 indicates also the last time since the activation and the remaining battery capacity. On the third burst, again, transmit the reference number 2. The position is updated. We have a reference position. The beacon has been informed that the beacon has been heard by the GOSPAS-SARSAT system, and the RLM type in the section 6 indicate that this has been received. The automatic acknowledge has been received. This is information that comes in the beacon feedback field. And in the last of the 3 cancellation bursts, the number 6, the Spanish MCC or the MCC in question will send to the SPOC information that the cancellation is confirmed and send in the first line a cancellation alert. A little bit of disclaimer is that all this has been manufactured almost manually using my automatic system, but at the same time I have to go to the documents and check everything because all of this is the future.
Thank you very much, Mr. Siban, for your presentation and for your answer to the question. Thank you very much.